Welcome to the wonderful world of disk files. This video is really part of a series. This video covers Stream I/O and how to open and read a disk file. Another video in the series covers how to determine the mean, which is known as the common average, and the median value of a file that contains some numeric data. First thing I'd like to do is discuss streams. A stream typically is made out of water, and water flows from one part of the stream and usually flows downhill and it goes to another part of the stream. Well, we have something similar with data. With data, we can have data flowing from a keyboard through a program and then over to a display. Or it could flow from the keyboard, go to the program, and then maybe to a printer or something else similar to that. In those days, the operating system would have one set of code to work with a keyboard and something completely different to work with a disk file. It made it kind of hard when you're writing the program, the application program, because all the commands were completely different for the disk file and the keyboard. So Doug figured out a way to how to make things so that they all worked the same for somebody writing a program, an application program. The way we could do that is to have everything look like the most complex device, which in this case was a disk. A common interface makes it easy to go from one device to another. In C++, to work with a console, I use cn, and then I could read into a variable, so I could say cn greater balance, and that would read some numeric data from the keyboard and stick it into a variable named balance. If I want to display that, I'd say cout for console out less than balance, and then that numeric value would be displayed on the monitor. A little extra work, because if we're going to work with a disk file, we have to open the file and a few other things. But as far as doing the data, if I said in file greater balance, see how similar that is to working with the keyboard, or out file less than balance, and that would stick stuff onto a disk file. Once the program has been set up, the interface to a disk file, it's just about as easy to read and write data to a disk file as it is the keyboard and the display. One of the things people do is put all of their data on the disk. That way you don't have to keep typing it over and over again. But there's also a slight difference. When we're working with the keyboard, I need a prompt. For example, if I want to read in a balance, I have to say, use a cout for a prompt and say, enter the balance, and then cn, and I can read the balance from the keyboard. If the balance is on a disk file, I don't need the prompt. All I have to do is go and read it from the disk file. We have some standard I/O devices, and as far as a program is concerned, when a program first loads from the disk, the operating system automatically opens these 5 files. Well, not all are used anymore, but we have the standard input, and the default device is our keyboard. The standard out and standard error devices, the default device is the display. Standard print, well, we may have to make sure that we're actually going to know which device is the printer, and then we can output to stdprn. We can output to that device. And the auxiliary device, stdaux, really isn't used anymore, because that was an old-fashioned modem that would hook up to the telephone line. Here are some examples of just using the keyboard and the display. I have a variable called ID, another one score, another one name, and this is a character array. What I'd like to do is, let's say, enter ID, cout, enter ID, then console in, and I read in the ID into that variable. And console out, enter the name, and then I'll use another cn and put it into the name variable. And I'll say console out, enter score, and then I'll use console in to put it into my variable called score. If I look at my data stream, all the data that's coming in from the keyboard, I have 8317 and then the enter key, and that's what's going to go into the score, and then Dan, D-A-N, and then the enter key, and that's what's the what's going to go into the variable name, and then 27, and that goes into the score. So far so good? Well, what's whitespace? Whitespace is either the return or the line feed or the tab or a space, and it can give us some problems. For example, if I say enter ID and I type in 8317, that's fine. Say enter name, and then I type in Dan space McElroy. Big problem, because what's going to happen is, see the space in there between the Dan and the McElroy? Console in stops reading a field when it sees white space. So it's going to stop reading the name at the space. You can also have problems like Jose de la Cruz, because there's a space. It's one name, de la Cruz is the last name, but there's spaces in the name. So we're going to have to be careful on how we actually do some of the processing here. And here's really what's happening is, say enter ID, the 8317 goes into the variable ID. We say enter name, and we're going to stop reading at the space. So the rest of this stuff is still sitting in the input buffer. And then when I go around, I say enter score, what's going to happen is McElroy is sitting in the input buffer. I'm going to try to read the score, but I pick up the M instead. So I don't even get to the point where I read the score, because I have some text data there, not numeric data. It's characters. Bad. Well, maybe I should check and say if cn.fail, I can check to see if I was able to actually read the score in there. We have similar problems with the disk file if the data does not match the data types that we have written in our program. Well, here's some other things. C and C++ languages can do many things besides just reading the file. We can open the file for reading. We can open it for appending. That means add more data onto the end of a file. We can seek, means move our file position to somewhere in the middle of the file. Rewind goes all the way back to the beginning of the file. Close closes the file. Reopens, closes it and reopens it. And open, we have some other things. We can say open in a text mode and open in binary mode. This discussion only covers the text files. If you wanted to open something that was not text, you would need to open it in binary mode. For example, it's a picture or a database or maybe even a Word document. They're not stored as pure text. There are some differences between C and C++. The C language uses a file pointer that references a structured record that contains information about the file, and C++ uses stream objects. And I'm only going to cover the C++ stuff in this video. Before we can do anything at all with the file, we have to open the file. And what we mean by open, we have to establish a connection between our program and the file that's on the disk. We end up actually with two names. We have a file name that's on the disk, and then we have the name of the object in our program that's going to be used to work with the file. A disk file must be open. Here are some examples. I start off with an include. I have to say include less than Fstream and then a greater than. That brings in the include file for all of our file stream. Fstream is for file stream. That has all the stuff to open the file, to work with an input file, and to work with an output file. I have to establish the connection between the disk file name and the object that I'm working with in my program. In this example, I say character file name equals quote balances.txt. So this is going to be the name on the disk that I'm going to be using. ifstream, input file stream. So I'm going to create an object. Class type is ifstream. That means input file stream. And the name of my object in my program that I'm using at the moment is infile. Now you can call it anything you want. as long as it's a legal name. Then throughout your program, to work with that file, you would say infile. I can say infile.open. .open is a member method. Infile.open and the file name. Now actually you could even put infile.open and then you could have the quote balances.text quote inside those parentheses, so you can actually put the file name in there, or you can put in a variable. I need to see if there was a problem when attempting to open the file. Maybe the file did not exist. I'll come up with an error. Maybe the file is on a network and that network connection is down. Maybe another program has the file open and it's locked and I can't open it until that other program is done with the file. Maybe I'm trying to open a file for writing, open an output file, and that file is tagged as read-only. So there's always a possibility that open didn't succeed. So when we try to open a file, we really need to check and make sure that the open was successful before we continue on with the rest of the program. If it's not successful, we can put up some error message and then kill the program. A little bit more information on the name of a disk file and the name inside the program. For example, if I have a file called balances.txt on the disk, I can't use that name directly inside the program. I have to use the open command. I'll say include Fstream, and somewhere in the program I'll say ifstream infile, semicolon. Infile is going to be the name of the object inside of our program. Now I can say infile.open and then balances.txt. That's going to make the connection between the disk file and my program. I can even fully specify a file and its path name. This would be fully specified. For example, if I put balances.txt on the desktop, I could say for the file name, quote, /user/Dan, and here you have to put in whatever name you're using to log in, /user/Dan/desktop/balances.txt. In Microsoft Windows, you may also have to specify the name of the disk, so it might start off with, quote, C:/users if your program is running from a different device. There's an easier way to do it. I could say, instead of 2 lines here, ifstream infile, I could open the file at the same time I am creating the object. ifstream infile file name. We need to know the data. For example, in this case, this is an account number followed by 1 or more spaces or a tab. It really doesn't matter. It's just white space in there. And then a user's name. And notice I have an underscore there in between the first and the last name. It makes it a little bit easier to process. And then I have the account balance. I'm going to do 3 options here to show how to read the file and display it to the monitor. The first option is I'm going to do character by character. So I'm going to open up the file, and then in the file statement it says file not infile.eof, that means end of file. While I have not reached the end of file, I am going to get 1 character from the file, put it into the variable ch, and then display that character. It's going to go through and loop and loop and loop all the way through the file statement until I hit the end of file. Get 1 character and display it. Get another character and then display it. Get another character and display it. This time I have a return 0 when I'm all done. And the 0 is just an indication that I did not have a problem. Oh, here's what it's going to look like. It's just going to display all of the data. That's pretty cool. Okay, here's another option. I'm going to read 1 full line at a time and then display the line. So inside the while statement, it says while not infile.eof, while I have not reached the end of file, infile.getLine, that's going to read 1 full line of text from the file. It's going to go into a character array I called buff, short for buffer, and 100 characters, no more than 100 characters because that's the buffer size. Interesting thing about getLine is that the end of line is not stored as part of the input. So when I do the console out, I have to say console out less than buff. That displays the entire line, but I also have to use an ENDL to move the cursor down to the next line before I read another line and display it. Otherwise, everything's going to be on one line. The third option is a little bit more complex because I'm going to read the data into 3 separate variables. I'll create my variables, account, name, and val for balance. In file, greater account, greater name, greater balance. What's going to happen is I'm going to read from the disk a numeric value into account and stick that into the integer. Then I'm going to read up to 100 characters of the name and stick that into the name variable. It's an array of characters. You have to be careful to make sure there's no spaces in the name. That's why I used underscores here instead of spaces. And then I'm going to read the balance and stick it into a variable called balance. I'm going to be using the Sentinel value type method for reading, where I read the first record before the while loop, and then the last thing I do in the while loop is read the next record. So it's going to display the account, quote, \t, quote, that's a tab. So it's going to put a tab in between each of those, each of the fields. Now, when you display this, you may notice that stuff doesn't always line up because tab goes to the next 8th position on the screen. So if something is like 5 characters for a field, then we're going to end up skipping 3 blank characters and we'll go on. But if another field, another record in the same field has like 9 characters, then we've already gone past the 8th character, so then we're going to start the next one at the 16th. So sometimes we'll start at the 8th, sometimes we'll start at the 16th if the date is not all the same width. And maybe later on we can figure out how to read those things because we'd like them to be the same width. So if you look at IO manip, you can make your field widths a constant size.